Hello friends, welcome back to our YouTube channel. In this video we are going to solve a few more problems. Let's start with the first problem. Before that, let us learn a concept which we have left in the previous video. That is, suppose this is A vector and this is B vector. We have learned the geometrical meaning of vector product earlier, that this is A vector, this is B vector, then A cross B is the area vector of this parallelogram with A vector and B vector as its adjacent sides. Now, this half area of this parallelogram or the area of this triangle will be half of A vector cross B vector. It will represent area of a triangle with A vector and B vector as its adjacent sides. Since this is a vector quantity, it will be the area vector. It is not scalar. The magnitude of this area will be magnitude of half of mod of A cross B. Now let's solve the first problem. Here we are required to calculate the area of a triangle which is formed by the adjacent sides. A vector is equal to 3i cap plus 4j cap, B vector is equal to minus 3i cap plus 7j cap. Suppose this is A vector and suppose this is B vector. Now we have to find the area of this triangle. Now we know that the area of this parallelogram, the magnitude of the area vector of this parallelogram is given by A cross B, a whole magnitude, and the area of this triangle is given by half of the magnitude of A cross B. Therefore, required area will be simply half of magnitude of A cross B. Now, it is given as half of magnitude of A cross B is this determinant I cap, J cap, K cap. Here the K cap component is 0 times K cap, here also 0 times K cap. So 3, 4, 0, 3, 4, 0 and minus 3, 7, 0, minus 3, 7, 0 and its whole magnitude. This represents the magnitude of this determinant. This is the determinant. Now we have to open the determinant. We have half of I cap times magnitude of 4 multiplied with 0 minus 7 multiplied with 0, which is 0, minus j cap times 3 multiplied with 0 minus 3 multiplied with 0, which is 0, plus k cap times 3 multiplied with 7, which is 21, minus 4 multiplied with minus 3, which is minus 12. So we are getting this as 21 plus 12, 33. This is K cap, a magnitude which is 33 upon 2 square units. This is the answer of this question. In question number 2, we are given 3 vectors. A vector is equal to 3i cap minus 2j cap plus k cap. B vector is equal to I cap minus 3j cap plus 5k cap, and C vector is equal to 2i cap plus j cap minus 4k cap. We are required to prove that this ABC constitutes a right angle triangle. First of all, let us prove that ABC forms a triangle. For 3 vectors to constitute a triangle, we have learned from the triangle law of addition that sum of any 2 vectors should be equal to the third vector. That is, one of these given vectors will be equal to the vector sum of the other 2 vectors. Now, by observation, we can see that B vector plus C vector is basically 2 plus 1, 3i cap minus 2j cap plus k cap, which is equal to A vector. Therefore, we have proved that the sum of two of the given vectors is equal to the third vector. Therefore, ABC constitutes a triangle. Therefore, ABC constitutes a triangle. Now we have to prove that this triangle is a right angle triangle. Now by heat and trial method we can find A dot B, B dot C and C dot A. And in case of the dot product, we know that if two vectors are perpendicular, then their dot product is 0. By heat and trial method, let us first find B dot C. Multiplied with 3 plus 1 multiplied with minus 2 plus minus 4 multiplied with 1. Here we are getting 6 minus 2 minus 4, which is 6 minus 6, and it is going to be 0. Therefore, we can see that B vector is perpendicular to C vector. Now we can draw the figure also. Suppose this is B vector, and we have also learned that B plus C is going to be A vector. This is suppose C vector, and this is suppose A vector. From this diagram, by triangle law of addition, you can see B vector plus C vector is A vector, and B vector is perpendicular to C vector. So we have proved that ABC forms a right angle triangle. Next question is question number 3. Here we are required to determine the unit vector which is parallel to the cross product of A vector and B vector. This vector. Here we are given A vector as 3i cap minus 5j cap plus 10k cap, and B vector as 6i cap plus 5j cap plus 2k cap. Now we know a unit vector along any vector C vector is given as is equal to C vector divided by magnitude of C vector, as we have already learned in the previous video lectures. Therefore, we are required to find, let the unit vector be this n cap. We are representing the required unit vector which is n cap, which is equal to A cross B divided by magnitude of A cross B. This will be the required answer. Now first of all we have to find A cross B. A cross B will be equal to the value of this determinant I cap, J cap, K cap. 3 minus 5, 10. 3 minus 5, 10. 6, 5, 2. 6, 5, 2. Here we are getting I cap minus 5 multiplied with 2, which is minus 10, minus 10 multiplied with 5, which is 50, minus j cap 3 multiplied with 2, which is 6, minus 10 multiplied with 6, which is 60, plus k cap multiplied with 3 multiplied by 5, which is 15, minus 5 multiplied with 6, which is minus 30. So it will result in plus 30. So the answer is going to be minus 60 I cap. 6 minus 60 is minus 54. This minus minus plus 54 j cap. 30 plus 15, 45 plus 45 k cap. This is the required vector A cross B. Now we have to find the magnitude of A cross B. So we are getting minus 60 whole square plus 54 whole square plus 45 whole square. You can simplify this statement and the result will be square root of 8541. Therefore, now we can find n cap. equal to A cross V, which is this, minus 60 I cap plus 54 J cap plus 45 K cap divided by square root of 8541. This is the answer of this question. Now our next question is question number 4. Suppose we are given that magnitude of A vector plus B vector is equal to magnitude of A vector minus B vector. Then we are required to prove that A vector is perpendicular to B vector. This can be achieved by the statement A vector dot B vector is equal to 0, as we have already seen. Now we know that magnitude of A vector plus B vector whole square is equal to A vector plus B vector dotted with A vector plus B vector. We have already learned. Now let's open the two brackets. A vector dot A vector is mod A k square plus A vector dot B vector plus B vector dot A vector. So 2 times A vector dot B vector plus B dot B, which is mod of B vector ka whole square. Similarly, we can find A vector minus B vector ka whole square, which is going to be equal to magnitude of A vector ka square minus 2 times A vector dot B vector plus magnitude of B vector ka whole square. Now, squaring both sides in this equation, squaring both sides, this is given in the question. We are getting this equal to this, therefore this equal to this. Magnitude of A vector ka square plus 2 times A vector dot B vector plus magnitude of B vector ka square is equal to magnitude of A vector ka square minus 2 times A vector dot B vector plus magnitude of B vector ka square. Both these terms get cancelled. Therefore, we are getting 4 times A vector dot B vector equal to 0, or A vector dot B vector is equal to 0. Therefore, we are getting A vector is perpendicular to B vector, hence proved. Now, in question number 5, we are given this diagram. Here, AB is equal to 5 meter, which is AB is making 37 degree with the positive direction of x-axis. BC is parallel to x-axis and it is equal to 3 meter. CD is equal to 2 meter, which is parallel to y-axis and perpendicular to x-axis. We are required to find the resultant of these 3 vectors. The best way of finding the resultant is to write the given vectors in I cap J cap format. So let us first write AB vector in I cap J cap format. For writing in I cap J cap format of any vector, we are required to find the components of the given vector along the I cap direction and J cap direction and K cap direction. The component of AB vector along I cap direction, this direction is I cap direction or x-axis direction, is 5 cos 37 degree. 5 cos 37 degree times I cap plus 5 sin 37. This represents the component of this vector AB vector along y-axis, plus 5 sin 37 degree times j cap. Then we have BC vector as 3 I cap and CD vector as 2 times j cap, because BC vector has no component along y-axis and CD vector has no component along x-axis. Therefore, now we can find the resultant vector R vector as AB vector. AB vector by head-tail combination, we can write AB vector plus BC vector plus CD vector is going to be this resultant vector plus BC vector. We are using the triangle law of addition, plus CD vector. Here we are getting this cos 37 is 4 upon 5. Cos 37 is 4 upon 5. So this is equal to 4 I cap. Sin this 37 is 3 upon 5 plus 3 j cap. So 4 I cap plus 3 I cap is 7 I cap. 3 j cap plus 2 j cap is 5 j cap. So this is the required vector. This is the resultant vector which we are required to find. Next, in question number 6, we are given this diagram. This is OA vector whose magnitude is 5 meter. This is OB vector whose magnitude is required to find, and OC vector whose magnitude is also unknown. But we know that OC vector is making 45-degree angle with this direction. So, and we are given that OA vector plus OB vector plus OC vector is equal to 0 vector. And from this statement, we are required to find magnitude of OB vector and magnitude of OC vector. From this diagram, we can write all the vectors in I cap J cap format. Let magnitude of OB vector be equal to x and magnitude of OC vector is equal to y. So we can write here x meter and this is y meter. Now we have OA vector is equal to, its magnitude is 5 and its direction, and this direction is j cap, therefore this direction is minus j cap. Minus j cap. OB vector, its magnitude is equal to x and its direction is given by I cap. OC vector, now we are required to find OC vector. We can resolve it into two components. This x component is y cos 45 degree, this will be y sin 45 degree. This x component is y cos 45 degree and its direction is in this direction. The resolving vector will be in this direction, so this direction is minus I cap plus this resolving vector will be in this direction, which is y sin 45 degree, and it will be in the direction of j cap. So this will be y upon root 2 minus y upon root 2 I cap plus y upon root 2 j cap. Now we have to use this given statement. OA vector plus OB vector plus OC vector is equal to 0. Let's add all these three vectors. X I cap minus y upon root 2 I cap. X I cap minus, we can take I cap common also, x minus y upon root 2 I cap minus 5 j cap plus y upon root 2 j cap plus y upon root 2 j cap minus 5 j cap is equal to 0 vector. We can write 0 vector as 0 I cap plus 0 j cap. Now we have learned from equality of two vectors that two vectors are equal when their x components, y components and z components are equal. Therefore, we can equate the I cap terms. That means x minus y upon root 2 is going to be 0. Let's rub the board. X minus y upon root 2 is going to be 0. Therefore, we are getting first equation as x equal to y upon root 2. Next is we have to equate the j components. This y upon root 2 minus 5 is going to be equal to the j cap component on the right hand side, which is 0. From here we are getting y is equal to 5 root 2, which is the magnitude of C vector, OC vector. This is one answer, and from here we are getting x is equal to y upon root 2, that means 5 root 2 upon root 2, which is equal to 5. This is meters, this is also meters. This is equal to magnitude of OB vector. This is another answer. Hence we have determined. Now we should note one shortcut, that is, suppose this is A vector and suppose this is B vector. Then how to name this vector directly? This vector is going to be B vector minus A vector. B vector is the vector towards which this vector points. In this way we can remember. And this vector is going to be A vector minus B vector. We can note from triangle law of addition also. Suppose we are observing this B vector minus A vector and B vector. This is A vector plus B vector minus A vector is going to be B vector, and this is the resultant B vector. In this way we can write directly the vectors. Next we are going to solve one important question. Question number 7. Suppose we have this pyramid. We all know that pyramid is a 3D structure. This is O, this is A, this is B, this is C. Now we are required to prove that suppose this area OBC, the area vector will be along outward normal to this plane. We are taking this plane OBC. Suppose the area vector points in this direction, which will be always perpendicular to the plane, is suppose n1 vector. Similarly, the area vector of OAB vector is n2 vector, OAC vector is n3 vector, and ABC, that means this plane which will be in downward direction, is n4 vector. This vector is n2 vector. And OAC vector, which will be in that direction, will be n3 vector. Now we are required to prove that n1 vector plus n2 vector plus n3 vector plus n4 vector is going to be 0 vector. To prove, this is the question we are going to solve. Suppose we take this as OA vector, this as OB vector, and this as OC vector. Let OA vector be represented by small a vector, OB vector is represented by small b vector, OC vector is represented by small c vector. Then the concept which we have learned just earlier, and using that concept we can write BC vector as C vector minus B vector, C vector minus D vector, and similarly BA vector as A vector minus B vector, A vector minus B vector. This is A vector minus B vector. Now, by the geometrical meaning concept, we can write, let us take n1 vector, first write n1 vector. N1 vector is going to be this area vector, which is half of OB cross OC. Half of OB vector cross OC vector, that means B cross C. B cross C. Since it will be along outward normal, so we have to note the direction also. B cross C. By right hand thumb rule, if we place our right hand towards along B vector, then we can see it will result in outward normal. So this is correct. Then n2 vector is equal to, n2 vector is going to be this vector, therefore we have to cross A with B. It means half of A cross B. Then we take n3 vector. N3 vector will be along that direction. Therefore, we cannot cross in this way. We have to cross in this way. Therefore, we will first take C vector. Then we will take A vector. So half of C cross A. Now, next is this vector BA vector cross with BC vector. Now if we cross in this way, the thumb will point in upward direction, so the area vector will not be along outward normal. The outer normal is in downward direction, which we have already represented by this arrow. So therefore we have to cross in this way. So the first vector will be A vector minus B vector, and for vector half of, we have to take the cross product of A vector minus B vector cross with C vector minus B vector. Now we have to write left hand side, which is n1 vector plus n2 vector plus n3 vector plus n4 vector. Let us first simplify this equation. A cross C minus A cross B. We take half inside the bracket. A cross B minus B cross C minus half of B cross C plus half of B cross B. B cross B is going to be 0 because both these vectors are parallel vectors, and we know that cross product of parallel vectors is going to be 0 because the angle of these two vectors is 0, therefore sin 0 is 0. Now we have to add these three vectors. If we add these three vectors, then we can see half of B cross C plus half of B cross C and minus half of B cross C gets cancelled, plus half of A cross B gets cancelled with minus half of A cross B, and plus half of C cross A is equal to, we have already learned that A cross B is basically minus of B cross A, therefore C cross A is going to be minus of A cross C. So here we can write minus of half of A cross C. So minus of half of A cross C added with plus half of A cross C get cancelled. So we are getting n1 vector plus n2 vector plus n3 vector plus n4 vector is equal to 0 vector, which is this statement. So we have proved. Thank you.